Good morning, esteemed judges. Today we are going to explain to you the art of mathematical science, that how maths is important in science. My name is Gyan Heather.
My name is Muhammad Ashif.
My name is Mohammed Abdul.
So we are having credits here Muhammad Ashif, Ryan Heather and Abdurrahman, which we have basically told you before.
First of all, we will explain to you how addition, subtraction, and multiplication and division are useful in science. These fundamental operations are essential for calculating molecular masses, volumes, and other quantities within chemistry and physics.
So over here addition, subtraction, multiplication and division are parts of maths. But here the maths, these types of units can also be used for calculating molecular masses, volumes and other quantities which are of chemistry and physics. So maths, addition, subtraction, multiplication and division is interlinked with science.
Unit conversion, which is used to convert units from a meter to centimeter and grams to kilograms.
So these units are parts of mathematics basically, and these are meters, centimeters, grams to kilograms. These are measurements used in sciences. So it means that unit conversions includes maths and sciences both.
Significant figures are used to express precision of measurements during scientific figures.
So here in the science we use the precision of measurements which are very much of significant figures, ensuring accuracy in calculations. So for ensuring accuracy we use figures which are parts of maths, and like this maths and science are integrated.
Exponents and logarithms. These are some mathematical tools which help us to describe exponential growth.
So here exponents and logarithms are parts of maths, and here the rates of change in natural processes are basically part of science by decay.
Now we are going to explain geometry in science. First of all, we have symmetry, which means geometrical principles underpin the shapes of molecules, crystals, and biological structures.
Symmetry is basically a principle or a chapter of maths which we learn daily in our daily life, and here the geometric principles, the shapes of molecules, crystals and biological structures are basically interlinked with symmetry and shows how geometry is linked with nature in our science.
Reflection is also part of geometry, which is used to understand how shapes mirror each other at atomic level.
Reflection of shapes is part of the maths, but also the reflection of shapes at atomic and macroscopic levels also tells us how math is linked with the how geometry is linked with the nature.
Now we are going to talk about shape and structure. First of all, there are geometric shapes, which describe the arrangement of different atoms in molecules.
We've already talked about geometry here, about the shapes which are basically part of the maths. But here the arrangement of atoms in molecules, like the here mentioned tetrahedral, linear, trigonal, planar are parts of science.
We have a new topic here called crystallography. This is just like symmetry, but is used to study crystal structures.
Crystallography is basically the learning of the crystals and is part of the science, and using symmetry we can easily learn it. It means that using integrating maths and science we can easily learn crystallography.
Now we will tell about mathematical models in science. Calculus applications. We will start with integration. Essential for understanding rates of change, areas under curve, and accumulation. Example: Newton's laws and thermodynamics.
So here the calculus is basically a chapter which is part of your O levels and A levels, which is used in maths. So here the rates of changes, areas like Newton's laws and thermodynamics are part of biology and physics, which we learn at your A levels and O levels.
Differential equations. Modeling dynamic systems. Example: population growth and chemical reactions.
So here the equations are basically part of the maths, and so the modeling dynamic systems like the population growth and chemical reactions, which are part of chemistry and physics.
Statistical models. Regression analysis. Fitting data to mathematical models. Example: linear regression and logistic regression.
So here the regression analysis is a part of science, and we fit the data to the mathematical models which are basically part of the maths and science here.
Probability distributions. Describing random events, example, Poisson distribution and normal distribution.
So probability is a chapter we learn in maths, and here the describing random events like just like random events of sciences, Poisson distribution and normal distribution which are of sciences.
Now we'll tell you the quantum sympathy mathematics in physics. Quantum mechanics. The role of complex numbers, wave functions and probability amplitude in describing subatomic particles.
So quantum mechanics is a very brief topic in a science area. So here we understand quantum mechanics using some numbers, wave functions and probability amplitudes, which are also used to describe the subatomic particles, which are basically part of physics and chemistry.
Next, Einstein equation. How geometry and tensors reveal the fabric of space-time.
So here the Einstein equation Einstein's equations are part of sciences which he found the value of E and pi, so he found it using the geometry and tensors which are part of maths.
Statistical mechanics. Using probability distribution to predict behavior at the atomic and molecular levels.
We use statistical mechanics in our science, and here the mechanics are part of science, and statistical are the statistics we use in maths, which can also be used to predict behavior at the atomic and molecular level of sciences. Now we are having here the data alchemy, the statistics and scientific research. So this can be used to uncover the magic of statistical tools in the scientific investigations. First we are having hypothesis testing. So here we have to determine if experimental results are statistically significant. Regression analysis, modeling relationships between variables. So here the regression analysis the variables is a part of science and math post. In math we use it to find some unknown value, and in variables in science we use it for conducting a fair test. And also experimental design, balancing control groups, sample sizes and randomization. Next we are having is mathematical ecology in the patterns of nature. So for this we are going to dive into the intersection of maths and ecology. So like now we have told you before the ecology, nature, and these are just like examples and roots of sciences. So first we are having population dynamics. So there are differentiated equations for the species interactions. Next we are having biodiversity indices, quantifying species richness, and so we are having here also the chaos theory, which is also of the unpredictable beauty. So chaos theory is a theory of maths and sciences both, which makes an unpredictable beauty. So for this we are going to unveil the elegance within the chaos. So first we are having non-linear dynamics, the butterfly effect and the strange attractors. So non-linear dynamics is basically a process which is in the maths, and it causes the butterfly effect as you can see in the picture here, and also it creates a strange attractors. Fractals revisited here the Mandelbrot sets and Julius sets, which is basically a part of the constellations and something like that. And deterministic chaos, the systems that appear random but follow deterministic rules, that it is made in randomly but it has to follow some rules. So the last thing we are having is the mathematical artistry, symmetry and the tessellations. So for this we are going to celebrate the aesthetic side of math. First we are having here the symmetry groups. It is from the Ascher's tessellations to crystal structures. So here the Ascher's tessellations is a part of maths, and the crystal structures are here of the sciences of chemistry and bio. Then is the golden ratio. It's the presence in art, architecture and nature. Golden ratio is the ratio of numbers which has been found by a great scientists in old times, and its presence is also included in arts, architectures and nature. Next is the Fibonacci sequence, which is we have already learnt in our classes. Fibonacci sequence is the sequence of numbers, how it is arranged, and it is for the spirals in the sunflowers and the pine cones. We're going to thank you for this. So, esteemed guests, Thank you for being with us on this journey from equations to symmetries. We have glimpsed the magic. We have glimpsed the magic that binds these disciplines. Until we meet again, stay curious, stay focused.